Okay, we have to take another integral from the MIT integration bee 2006, problem 29. We have the integral from 1 to square root of 3, 1 over square root of x squared minus 1 dx. Okay, now to get started with this, of course, this is a really common integral, and we could actually just use a formula on this. The interesting thing, I think, is just the bounds that we've got this. We're going from 1 to square root of 3. That's going to make it a little different. Now, I actually know two good ways to do this off the top of my head, just regular trig substitution and hyperbolic trig substitution. For this one, I think what I'm going to do is hyperbolic trig substitution. So what I want to do for this is make my substitution for x, and I'm going to say x is going to be equal to just cosh of t. Then taking our derivative, dx is going to be just sinh of t dt. And the reason I chose this substitution is we have this identity that cos squared t minus sinh squared t is going to be just equal to 1. So with just a little rearrangement of this, we also have cos squared t minus 1 equals sinh squared t. So what's going to happen is when we do this substitution, we're going to end up with sinh squared t inside the square root, and that's going to simplify nicely. And then while we're at it, let's just take this and let's get our value for t. So solving for t, taking the inverse on both sides, we have t equals to cosh inverse of x. And one thing we need to keep in mind with this is cosh t it looks kind of like a parabola. It doesn't pass the horizontal line test, so it's actually not invertible the way it is unless we restrict t. So the way we typically do that so that the inverse is a function is we're going to say that t needs to be greater than 0. So then we'll just go ahead with this substitution. So first of all, we have square root of 3. I'll plug in square root of 3 here, and I'm actually just going to leave it because I don't know what this value is. So I'm going to leave this as cosh inverse square root of 3. And then when we plug 1 in here, that's actually not too bad, but let's just do it out. So let's actually use this equation. We're saying our x value is 1, and we want to find our t value. So what I'm going to do is use the definition of cosh and write this as e to the t plus e to the minus t all over 2. And we could actually go ahead and manipulate this and solve for t, but what you'll notice is if t equals 0, we end up with e to the 0, which is 1, plus e to the 0, which is 1, so we end up with 2 over 2, or 1. So 0 is going to be our value here. That's going to work. And from here, we've got our dx value right here. So this is just going to become sinh of t dt. And then for our denominator, when we plug in x equal to cosh t, we're going to end up with this, cosh squared t minus 1. So what I'm going to do is I'm actually just going to rewrite it like this as sinh squared of t. But taking the square root of sinh squared of t, I can actually just rewrite this as the absolute value of sinh of t. And then I'd like to get rid of this absolute value. Now this is where we can use this condition that we set before, that we have t greater than 0. When t is greater than 0, sinh is always greater than 0. And so that just allows us to drop our absolute value. But also notice here we could have defined this the other way. We could have defined this as t less than 0. So then you just have a minus sign out front, and that would work out later when we deal with this right here. But now from here, sinh of t just cancel with sinh of t, and we're just integrating 1. So going ahead with that integral of 1 is just going to be t evaluated from 0 to this thing over here. And so then from here, evaluating at 0 is just going to be 0. So just evaluating the upper bound, we get a solution of just cosh inverse square root of 3. Now this right here is the solution that they got in the integration bee. So this was the correct solution, but there is another way to express this. Let's just see if we can manipulate this into a different form. Okay, so in order to rework this, let's just remember that this value from our integral, this was just our t value. And let's just use this equation right here and rearrange this. So if this is our t value, then this here is our x value. So using this, we have something like square root of 3 is going to be equal to cosh of t. So all I need to do is solve this equation for t in order to get a different way to express this. So what I'm going to do for that is use the definition of cosh, which is just going to be, I'll write it as e to the t plus e minus t all over 2, and we're saying this is going to be equal to square root of 3. But I can multiply a 2 on both sides to get it like this, and these 2's are going to cancel here. And then I'll just make a substitution in order to simplify this. I'm going to set y equal to e to the t. So then that way what we're doing, we have here y plus 1 over y equals 2 square root of 3. And then what I can do is multiply through on both sides by y. So when I do that, we're going to end up with y squared plus 1 equals 2 square root of 3y. But then I can get everything on one side of the equation. In order to have a quadratic, so this will become y squared minus 2 square root of 3y plus 1 equal to 0. And then what I can do for this to solve for y is we'll just use the quadratic formula. So this is going to be my b value. So this is going to be minus b. So that's going to give me 2 square root of 3 plus or minus square root of b squared. When you square this, you're going to just get 12 minus 4 AC, C is 1, A is 1, so it's just going to be a minus 4 here. And this is going to be all over 2A, which is just going to be 2. Simplifying this is going to be an 8, so we're going to end up with y equals 2 square root of 3 plus or minus square root of 8 is going to be, I can simplify that as 2 square root of 2 all over 2. And the 2's are going to cancel here and here. So for our value of y and e to the t, we just have square root of 3 plus or minus square root of 2. And now from here, again, we don't want a value for e to the t, we want a value for just t. So we could solve that by taking natural log. But before we do that, I want to deal with this plus or minus. Now, in a lot of cases, you may just want to drop the minus. And of course, because e to the t is always going to be positive, it's an exponential, that makes sense, except for the fact that notice that even with the minus sign, it's still positive. Square root of 3 is like 1.732. Of course, it's bigger than square root of 2, but even with the minus, right? If square root of 2 is like 1.414, this is something like 0.3. So the negative is still positive. But what's happening here when we actually take the natural log on this in order to isolate the t, well then now this is less than 0. So this 0.3 value is still a problem, so it's going to create a negative t when we take the natural log. If we add these two together, the value is something like 3.1 something. You take the natural log of this, it's greater than 0, it's actually greater than 1. So the positive of this is going to be no problem, so I'm just going to remove this and we're just going to keep. And so we can just keep the positive value on this and get rid of the negative. And so from here, all we need to do is apply natural log on both sides. Natural log of e to the t is just going to give me t here. And then here we're just going to have natural log square root of 3 plus square root of 2, and that's it. Okay, so there you have it. Kind of some over analysis on a pretty simple problem. Thanks everyone for watching. Have a good day.